So this is section 11.1 in math analysis. Now in the old video, I made an error. Area is 1/2 the absolute value of the determinant because it's a triangle. So I didn't put the 1/2 in the front. A student caught that, which is awesome. Anyway, so of course there's a 1/2 in the front. It's a triangle. Triangles basically always have a 1/2 in the front. Anyway, so I apologize for that. That was in the last video. Okay, that was the area of a triangle given just the coordinates of the endpoints. Okay, so this is going to be 3D vectors. That's what we're doing today. 3D vectors. Okay, so one thing is plotting a 3D point. So plotting a 3D point, I wish I could describe it to you better. I wonder if I could describe it to you well on this video the way I usually do in class. So what I do in class is this one that I just made, I put on like a Post-it note or a piece of paper. So let's see if you can do this. So XY, so let's put real life. Okay, so let's see if we can do this, put real life. Okay, so XY, you're going to draw that on like a little sticky note, okay, or just a side piece of paper. Okay, not the one you're writing on, but a side piece of paper. And you label it XY. And then what I do is in the middle, so right here, in the middle, I make a hole where the blue dot is. And I put my pencil or pen up through the blue dot. Okay, so what you have is you have part of your pen going into your screen, whatever you're looking at for my personal one that you're looking at for my notes, is one is going into the screen and one is coming out right where between your eyes and the screen. Okay, so your pen is connecting like your eyes to the blue dot, and then you keep going straight through. On the piece of paper, it looks like the z-axis is coming straight up towards you, like up in the air, and then down through the desk, if you're writing on a piece of paper and not a screen. Okay, so that's called the z-axis. Now, the way that it's drawn, so I'm just going to put a little note here that says z-axis, z-axis, straight up and straight down. Now, the thing is when they kind of reorient you, when they make the ones that they draw in the book. Okay, there's two ways they can draw the ones in the book. Okay, and this is the way we draw it on paper. So what we actually do when we draw it on paper is we actually draw the z-axis here, the y-axis here, and then forward and backwards they draw slanted like this. So I don't know if you can imagine the 3D of this. Okay, but the x is forward and backwards. So let me write that for you. So the x is forward and backwards. The y is right and left. And the z is up and down. Okay, so it works real well on the paper when you're writing on it to be thinking of the z-axis coming right up at you. But when we're drawing a picture of it, it's like our x, let me highlight these in green. Our y-x-axis is our piece of paper. Okay, so this is like a right angle. So this is our xy axis. Okay, that's flat on the desk. And then the z-axis is up through the paper and down through the paper. If you did make the little stick that we usually make, so with the little Post-it and then I wonder if I could do this with the camera. Let me see if I could do it with a camera. This is kind of fun. Let's see, I have a camera app on my phone. So let's see if I can describe it better for you. So I'll show you, and then we'll see. Now, if you see my desk, it's a huge mess, so don't be alarmed. Okay, so let me show you what I'm imagining. Okay. And then I'll put my hole through it. Okay, so let me see if I can show you with my camera feature. That'll be cool. So let's see if I can describe this better. Because 3D is a little weird. So usually it's in real life, obviously. So that's what 3D is all about. Okay, so let's see. Let me get to my camera. Here's a camera. Okay, so this is what I drew. Okay, I just drew a piece of paper. I just drew an XY axis. And then it would be helpful if you label it. This is going to help you with the quadrants. Okay, so with the quadrants, oh, it's like this, I guess. Okay. I was just looking at the buttons on my screen on the top. So it looks like it's going to be vertical like this. Okay, so the x-axis right here, okay, isn't this the first quadrant? So we're going to call this quadrant 1. And then this is quadrant 2. And then this is quadrant 3. And this is quadrant 4. The quadrants are going to be important for something else that we do. This is quadrant 4. Okay, and then what you're doing is what I'm trying to describe is you're putting your pen, okay, up through, hold on a second, see if I can do this and hold it at the same time. Okay, you're putting your pen up through here. Okay, this is cool. Cool, but a little awkward. Okay, so you're putting your pen up here. Okay, there you go. And do you see how you have some of your pen below, then you have some of your pen above? Okay, so there's my below of my pen. There's the above of my pen. Okay, so basically, here, let me flip my credit card over here. Okay, so we have this. And now, the way the picture is in the notes is the X is towards you. Okay, so the X is towards you, and the X is left and, or the Y is right and left, and the Z is up and down. Okay, so if you look at the quadrants, because we're going to have to do quadrants, and we do something called octants, is this is how it's referenced. Okay, so you are looking at this angle, and the first quadrant, the first octant is actually above the first quadrant. And then, okay, we lost the picture. Let's see. Okay, so the first octant, it's right here. It looks like this. So the first octant is on the right side of the X, and then it's above this paper. That's called the first octant. And then the second octant is above the second quadrant. Okay, so that's a positive Z, but you're really in the normal XY second quadrant. And then the third octant, so if I could make this stay up, not sure I can make this stay up. Oh, I had this student, he made me this cool thing. Maybe I can make it stay up through here. Let's see. Hey, that's kind of cool. Okay, so let me show you physically where all the octants are. Oh, what should I use here? I will use this bag of tea. Okay, so this section right here, okay, where I'm holding the yellow, okay, so this is called octant number 1. It's this part right here. Octant number 2 is right here. Octant number 3 is over here, above quadrant number 3. Octant number 4 is above quadrant number 4. And then you can see underneath, if you want to do, so this is octant 1, octant 2, octant 3, octant 4. And then you go underneath. So then this one's octant 1. Not octant 1. What am I on? 5? So octant 5 is underneath quadrant 1. And then you go under octant, under quadrant 2 is octant 6. And then you go over here where 3 is. See 3 is? That's 3. That's octant 3. But octant 7 will be underneath that one. Oops. Let's put the camera back in. I don't know why my camera keeps moving. Okay, so that's that. And then this one, what would this octant be? Okay, so that's quadrant 4. Octant 4 is above, and then octant 8 is below. So this is octant 1, octant 5, octant 2, octant 8, octant 3, and then octant 7. So if the Z is positive, then your quadrant matches your octant. And if Z is negative, then you add 4 to get that. Okay. Anyway, so let's get back to the other thing. So the trick here is, how do we draw this on the paper? Okay, so how do we draw this on the paper? So that's where the complications come. Okay, so how we draw it on the paper is like this. Okay, so forward is X, forward. Y is right, Z is up. So it's very hard to discuss where these octants would be and where the quadrants would be if we're drawing it like this. If I kind of drew it out, maybe like this, you could kind of see. Okay, this is actually quadrant 1 because the X and the Y are both positive. And then behind it would be back, I'd have to twist it actually. So it's kind of hard to look at from here. You can see the book. The book does a very good picture, but I like my stick one, my quadrant on a stick, and the quadrant on the stick really makes sense of where everything is. But to graph it, you use this. Okay, so to graph, you use the above one, but to check octants, it's going to be easier for you to do the one that we just did. So the one that we just did was X and Y, and this is quadrant 1, and this is quadrant 1, and quadrant 2, quadrant 3, quadrant 4. Now mine are twisted in the normal order that we do these quadrants. Okay, so what I do for octants, and octants aren't given Roman numerals, so these are quadrants. So what I do for octants is I first find the XY coordinate. Okay, so say the XY coordinate was -2, 3. Okay, you first figure out what quadrant this is in. Okay, so what quadrant would that be in? -2, 3. Now this is not how you graph it for real, but this is how you find the octants. So the quadrant is quadrant 3, and then you either add 0 or you add 4. Okay, so, except, that's so funny. That's quadrant 3. What did I say? Didn't I put quadrant 2? Okay, so this is quadrant 2, quadrant 2. Okay, so depends what the Z value is. So if the Z value was -6, then I would choose this one. Okay, so you add 4 if Z is negative, and you keep it 0 if Z is positive. So this would be octant 6. Octant 6. So let me show you another one, and then I'll show you how to graph the other ones. But let's say I have -3, -4, 5. How would we do that one? So what you do first, and I'll circle this in, we'll do this one in black. So this one right here, I first just look at the X and the Y, and I graph it like a normal coordinate, which would be here. So that would be third quadrant. And then should I add 0 or 4? So since Z is positive, the octant equals the quadrant. So you just add 0. The only thing is you call that octant 3, not Roman numeral 3. So that's how octants work. Definitely look in the book, though. The book has some better pictures than I'm drawing you. I really like the one that's on the stick. That way helps me imagine it the best. And then usually what I do is I turn the X and the Y back to the way that it looks for me. So let me show you on that. So camera, I wonder if the camera flips around. No, I won't. Okay. So back to this, my little stick here with my stand, is if I was looking at the quadrants from the way I just drew it for you, is I would flip it back to this way. Okay, so the one that I just did for you, we had a second quadrant, right? So we were over here in the second quadrant, but Z was negative. So the sixth octant, 2 plus 4, sixth octant is below the second quadrant. And then the other one that we did was over here in the third quadrant for X and Y. So the X and the Y in the normal positions. The third quadrant, it's in my third quadrant, but Z is positive, so it's up here. and that means it's also the third octant. So what if Z was negative on that one? Then that would be the seventh octant. Okay, so this is a good way to imagine it, but this is the way the graph looks. So the graph that we draw looks like this. So it looks a little strange. So that's why I usually twist it when I'm doing octants. When I graph it, though, I have to do it the way that they standardly do it, which is like this. But then they kind of twist the X a little bit so that it looks like it's coming up from sideways. And sometimes they twist the Y too, but that's difficult to do when you're drawing. Okay, so let me show you how to draw a point and not just find the octants. Okay, so let's go back here to OneNote. Okay, so for points. So if you want to graph it, okay, so let me show you how this works. So say you want to graph one of these points that I just did. So let's say I wanted to graph -2, 3, -6. Okay, which we determined was an octant 6. But what would you do if you wanted to graph it? Okay, so if I wanted to graph it, this is Y, this is Z, and then X comes out here. Okay, what I do is I actually graph these two first. Okay, the reason I graph these two first is because they're not slanted. So this is what I do first. So I do Y is 3, so 1, 2, 3, and then Z is -6, -1, -2, -3, -4, -5, -6. Okay, so here's 3, here's Z -6. And then I leave like little Hansel and Gretel, I leave breadcrumbs. Leave breadcrumbs so that you can see the path. And then after second, I do the -2 for the X. So forward X is coming out of the paper, but it kind of looks like it's to the left, but it's supposed to be going directly towards you. Okay, directly towards you. So negative means that you go back. So when you go back, what you do, I'm going to draw just like a little pretend x-axis. You draw a little parallel x-axis. But what we said is we're going back to. So you go back to like this, and then that would be your point. So this would be your point. We'll call this point A. So that's point A. Okay, so definitely do the breadcrumbs. You can also graph in the order that it says, but then when you go back to, when you go to the right 3, you can't go to here because this distance isn't 3. Okay, so what you would have to do, oops, let's put that X back in. Okay, so what you would have to do if you're going to do it this way is you have to go back 2, and then you go right 3 spaces, but it kind of looks like a parallelogram. So you don't go right to the spot that says 3. And so to me, that's a little awkward. So I would be going right 3 spaces like this. And then I would be going down 6. But again, I don't go actually to 6 because that would be too far. So I would have to then go down 6 from here. And yes, I land on A because I already knew where A was. And it kind of makes a little box. Okay, but to me, that's more difficult because, you know, this distance here from the green has to be 6, but it's starting up here above the x-axis or above the y-axis. So I prefer this, see this -6? I need that -6 to be the same distance as this one, but it's slanted. So the best way to graph them is definitely to graph, the Y and the Z first and then slant the X. There is another thing they do in the book sometimes. And what they do in the book sometimes is they'll draw the Z-axis here, and then they'll draw the X-axis and the Y-axis like this. Okay, and then, except that's the X, hold on, this one's the X. This is way too slanted. So it might be good to be able to read one of these, but to draw one, it's way too awkward. So I would say the most common way to draw it is the way that I drew it above. Okay, so don't do one of those slanty ones. Okay, so that's just graphing. Actually, the hardest part about 3D is the graphing. A lot of the rest of this section you're going to like. Okay, the graphing's just a little weird. Octants is a little weird. Okay, so let's see. Okay, so now we're going to do some things that make a lot of sense to you. Okay, so we're doing the 3D version, but it's for things that you already know. So distance formula, midpoint formula, and then the slope formula. Okay, so we have these: distance formula, midpoint formula, slope formula. So we're going to do 2D and then 3D. We'll do versus. So distance formula is D equals, do you remember 2D version? X1 minus X2 squared and Y1 minus Y2 squared. And then the 3D version is actually the same thing with the squareds. It actually comes from doing the Pythagorean theorem twice. Okay, comes from doing the Pythagorean theorem twice. Okay. And that comes from the fact that you're doing a box. Okay, so you're doing a box over here. And then let me draw the bottom of the box. Okay, you're doing the bottom of the box. And you're basically wanting the distance all the way across. So if first you find this distance by Pythagorean theorem, and then you find this distance right here, then this yellow hypotenuse is the length. Okay, and then this is a right angle. Okay, so it turns out that the red is, I'm going to call it delta x. That means the change in x. Okay, so I'm going to call this delta y. Call this delta x. Okay, and delta y is y1 minus y2. And delta x is x1 minus x2. And then this is delta z. It's easier to show you with that. So if I wanted the red, that's a right angle. So because if you imagine just the bottom, it's a rectangle. So that would be delta x squared plus delta y squared. That would be the hypotenuse, right? You can do a squared plus b squared equals c squared. And then what I would do to find the yellow, okay, to find the yellow is I would take the red, so I'm going to call that c squared. So this is going up. And I would add to it delta z squared. And that would equal my yellow squared, which is my distance squared. Now what's c squared? So c squared means that you would just be substituting this part right here in for the c. And then there's your formula. So you would get delta, I'm going to go up one more. We'll go up one more. So this would be delta x squared plus delta y squared plus delta z squared equals d squared. And then you could square root it. You could square root it. This is over here, deriving this formula. Okay, so this is deriving this formula right here. So it's kind of interesting. So it's actually Pythagorean theorem twice. Okay, midpoint. So what's the midpoint? So the midpoint formula has to do with averages. Okay, so think of it as average. Okay, so you're averaging each coordinate basically. And it is a point, so you should write it as a point. So midpoint, I want the middle of the x's and I want the middle of the y's. So I want the average of the x's and the average of the y's. And then that's the same thing. I average the x's, I average the y's, and then I average the z's. So that's the plan if I want the midpoint. Now the slope formula in 2D is m equals y2 minus y1 over x2 minus x1. Well, what are you going to do in 3D? Are we going to have like a big old stack? M equals like the z's over the y's over the x's? Delta z, delta y, delta x. Yeah, that'd be a big no. Okay, so we don't do it that way. So that's why we actually learned to use vectors. So what we're going to do instead is the vector that is going to be related to the slope, I call it the slope vector, is going to be delta x, delta y, delta z. So when we use vectors, it's going to link to that. Okay, and we're going to do vectors in section 11.2. So we're going to instead use vectors because we can't do slope. Okay, so this is a big no. There's nothing to do with slope. Okay, So let's see what else is in this section. Distance, midpoint. How would you tell if something is an isosceles triangle? Isosceles triangle. There's some homework questions that say find the isosceles triangle. Is it an isosceles triangle? How do you find if you have a triangle? Not drawn, because it won't be drawn. It'll just be giving you the 3D coordinates of each point. So how do you tell if it's isosceles? Does that have to do with angles? Does that have to do with sides? Is it more directly sides? Is it more directly angles? Have we talked about angles yet? I would say all we've really talked about is sides. So basically what you would do is you'd find the distance. We can call it distance 1, distance 2, and distance 3. And what should be the case if it's isosceles? Right? 2 of the distances are equal. 2 are equal. Right? If you had all 3 equal, what's it called? How do you prove something is a right triangle? That's called equilateral if they're all equal. So 3 are equal is equilateral. And 2 equal is called isosceles. And then usually we don't call equilaterals isosceles, although technically they are. Okay, right angle. So what if you wanted to prove, say, that this blue on the picture above was a right angle? How would you prove that that was a right angle? So you do look at the distances. You could also do the slopes, but I can't do the slopes in 3D, right? The slope should be perpendicular, flip it, change the sign. I don't have slopes in 2D and 3D, so what do I do instead? So what I can do instead is right triangles have to fit into the Pythagorean theorem. So if you find distance 1, distance 2, and let's call this distance B, for distance big. Well, let's just call it distance 3. Distance 3. But once you find all the distances, when you substitute it into the formula, if a squared plus b squared equals c squared, then it's a right triangle. Okay, and we'll put can't use slopes in 3D. So there's no slopes. There will be another method that you kind of learned in 6, but you're going to learn again. And then this one is going to be the largest one. Okay, so this will be the biggest radical. Just make sure that's in for your C. Okay, so you're going to use the distance formula on both of those types of questions. And it says, I think it says right angle, isosceles, or neither. It could be right and isosceles though. Okay, so let's talk about a sphere. Okay, and we'll compare it to a circle. So do you remember the formula for the equation of a circle? Or an ellipse, a hyperbola, do you remember those? Okay, but a circle specifically was x minus h squared plus y minus k squared equals, do you remember what it equaled on the right side? It equaled r squared. Now a sphere comes from the Pythagorean theorem as well, and it's made very much from the distance formula. So that's in the 3D. So you get the same thing, except what's different for a sphere? And then we'll just do the next letter. So the next letter is L squared equals R squared. And it is squared, it's not cubed in a sphere. Okay, and then the center of the sphere would be HKL. You do opposite, opposite, opposite. And then the radius is the square root of R squared. And then remember back from a circle, it was HK, opposite, opposite. And then the radius was the square root of R squared. Okay. Okay, so there's one question. There's a couple questions. It says just like write the equation of the sphere, but I'm going to do a more difficult one. Let's see if I actually have done any examples yet. Not really. I guess we'll call this example 1. We kind of did examples on the octants. We'll call this example 1. Okay, so it gives you 2 points. It gives you 2, -6. Oops, except it's 3D. So 2, -6, 8. And then it gives you another point, and we'll call this A. And B, it gives you another point. So this is -4. Let's see, we'll call this one -8. And then, what should I make this one? How about 12? Okay, so now it says these are the endpoints of the diameter. And it says write the equation of the sphere. Okay, so what in the world does that even mean? So I have a sphere. So let me just kind of draw a sphere so I can imagine it. So I have a sphere, and then you can put a center, and then what you do is you make like an ellipse, like that. Now I am not drawing A and B on that XYZ axis. Okay, that's not going to help me. But I'm going to put A here, and I'm going to put B here, just so I can make a plan. Okay, so I'm not going to put the actual coordinates because I have them there when I need them. So what two things do I need for a sphere? So what two things do you need to find the equation of the sphere? Okay, you need the center and you need the radius. So how do you think you find the center? So think about how you want to find the center. Okay, what's the center? We'll call it C. What's the center compared to A and B? Okay, and the answer is what? The midpoint. Now, what's the radius? Now, the radius, I'm going to use the distance formula, but which distance? Now, I have three choices, actually. The radius could be AB. No, the radius can't be AB. So the radius could be AC or CA, right? If you don't put a line on top, it means the distance. The radius could be CB or BC. Or what if I found AB? That's actually the diameter, right? So the diameter is AB. So what would the radius be? Half of AB. Okay, and when you write the AB like that with the capitals and A and B are points, it means distance. Okay, so these are the distance. So you get to use these three choices for this distance. Whichever one you want to use is perfectly okay. Okay, so let's do this one. We'll do this one as an actual problem. Sometimes in class we don't have time. So I just have you do it for homework and then you're okay. So center would be, and with the midpoints, I don't really write the formula first, nor the distance formula. I just write the numbers in. So it would be what? 2 plus -4 divided by 2, -6 plus -8 divided by 2, and 8 plus 12 divided by 2. So that would be the center. And you do want to show your work because when you get to calculus next year, they're going to expect that you show your work. Okay, so C is the center. See if that makes sense. Halfway, halfway, halfway. Okay, so that's my center. And then you get to pick which way to make the radius. It is actually easier to do AC or BC, but I'm going to do AB, which is the hardest way because you just have to remember to divide by 2 at the end. Okay, but I would say these two are better. Okay, but sometimes if your center is fractions, then maybe I would do the D method. Okay, so you do have a choice. So I'm going to do it the D method. So D is the distance. Now it's the distance between A and B. Okay, so it's the distance between A and B. So let's get our A and our B back. And you can subtract forward or backwards. You can do 2 minus -4 squared plus -6 minus -8 squared plus 8 minus 12 squared. Or you can subtract backwards because they're being squared. So that's plus, okay. So this is now what? 6 squared plus 2 squared plus -4 squared. You need the negative in parentheses if you're going to keep the negative there. So 36 plus 4 plus 16. So that is 20. That's 56. Square root, square root. So that's a D. Okay, but I need the radius. So sometimes I forget and don't find the radius. Like I forgot to take half of that one. Now, that's the radius, but it's unsimplified. So I'm going to leave it unsimplified just to show you what you can do with it. But you could simplify it and then work it out from there as well. That's probably what I would do in real life. When I write the equation of a circle, I don't write the formula. I just stick it right in. Okay, so let me stick it in another color so you can see it better. So it's x minus So it's x plus 1, right? Because it's minus a negative. It's y plus 7. And it's z minus 10. And then it's radius squared. So it's this and then squared. And then, oops, I lost my squared right there on the x plus 1. So x plus 1 squared plus y plus 7 squared plus z minus 10 squared. And you wouldn't be expected to multiply that out. And then this, we'll work this out up here so we don't have to write it again. That's actually 1/4 times 56 if you square each of them. And 1/4 times 56 is 14. Now I'm all like paranoid with my arithmetic. 4. Okay, 14. My other mistake videos. And that would be your answer. The equation of the sphere with endpoints of the diameter of the points that I gave you. You could substitute in A and B, and they actually are on the sphere, so they should make 14 if you wanted to check your answer. Okay. So let's do another one. We'll call this one example 2. You have 2x squared plus 2y squared plus 2z squared. And then I have plus 4x. I have minus 28y. Let's say plus 5z. Let's not do, let's do 10. 10z equals, they sometimes have the 20 on one side, they sometimes have it on the other side, so I was going to put 20, so let's do minus 20. Minus 20 equals 0. So let's see what happens. So what does it say? It says draw the sphere. Or there's some problems that say find the center and find the radius. So you have 2 types of problems that all relate to this. So what does it remind you of? It should remind you of something. Should remind you of completing the square. Okay, I think I'm going to divide everything by 2. What do you think? Divide everything by 2. Okay, so that's x squared, and I'm going to organize. So x squared, and then let's do the x next. So I'm going to put this one, and that's it right there. Plus y squared. Okay, so y squared, and who's y squared's friend? Negative 14y. And then I have this one, which is z squared. And that's 5z. And then I like to put my number on the other side. So I want to add that to the other side. And that's the 10. Now, why did I leave a gap? Do you remember do you remember what it's called? CTS. What does CTS stand for? So completing the square. Okay, so completing the square, do you remember the formula? 1/2 of your middle number and then squared. So that's 1/2 of 2 squared. Okay, so let's put a little note here. This is 1/2 of 2 squared. Now that's a plus 1. Okay, but you can't just put the plus 1 here. Remember, you have to also put the plus 1 on the other side. Okay. And then what do I put in the next one? So I'll put a little note over here. So that's 1/2 of negative 14 squared, which is negative 7 squared, which is 49. So I'm going to put that right here. Then I'm going to put the 49 right here. Okay, so remember, if you add it to one side, you have to add it to the other side. Okay, and then the 5z. Okay, that's more annoying. Isn't that annoying? So let's go up here and do that. So that's 1/2 of 5 and then squared. So that's 1/2 times 5 over 1. 5 over 2 squared is 25 over 4. Okay. So where do you put the 25 over 4? You put that here. And then you put that here. So you got to make sure you also put it on the right side. Okay, and then you factor each. Now, normally with math analysis students, they don't factor. Okay, so I'm going to write this factoring step in case you're helping a young'un in Algebra 1 or somebody in Algebra 2. It's helpful for them to see the factoring step before they write it as a squared. Okay, now this one's kind of complicated because you think, well, I don't know. But what it turns out to be, and let me circle it for you and highlight it in yellow. When you halved it, before you squared it, but when you halved it, that's actually the number, and I'm going to circle this and put this in blue. That's the number that goes in both of these spots. And you can check it. What's negative 5 halves times negative 5 halves? That's 25 fourths. And if you add them, except not negative, they're plus. If you add them, 5 halves z and 5 halves z, then you get 5z. Okay, and then probably you would have just written this though. Don't you feel like you would have just written this step instead? But it's okay to show the factoring step. It's really a step that's there. So I'm going to bubble this one to show you that this is optional if you want. Okay, so this is optional. So right now I'm just going to leave it 10 plus 1 plus 49 plus 25 fourths because I'm telling you that's an optional step and we have to make sure we do the rest here. So that's what, 11 plus 49? So 11 plus 49 is 60. 60 plus 25 fourths, right? Times 4 times 4. So that's 240. 240 and 25 is 265 fourths. And that would be equal to this. Okay, perfect. Unless I made a mistake, and then you guys will catch it and we'll write it in the notes. Okay, so 42, 4, yeah, I think it's okay. Okay, so what's the center? Opposite, opposite, opposite. And the radius is the square root of 265 over 4. So square root of 265 all over 2. Now, if I don't have a calculator and I don't know what this number is, I kind of have to guess. So what's 13 times 13 is 169. 14 times 14 is 196. 15 times 15. 16 times 16. 16 times 16 is 256. 17 times 17 is 289. So it's somewhere between 16 and 17. And then so I'm going to call it 16 plus. It's somewhere a little bigger than 16, but divided by 2 means I'm a little bigger than 8. Okay. So it says that I want to graph it. So let's see how we're going to graph this one. Now, some problems just say find the center, find the radius, and you're done. But some say graph it. So let's see what we can do. It is pretty big. Okay. Okay. Let me get on graph paper for you, because I know some of you take your notes on graph paper. Okay. Okay. Now, when you're graphing it, that's the y, this is the z. Okay, you can't put the x and the y in the usual spot unless you want to do octants. And then that, I always put it in the other spot. And then slanted is the x. And then you label it where the positive is. So you have to label the x in the front, not the back. Okay, the center, -1, 7, -5 halves. This is what, -2.5? Okay, so if you can remember what I suggested that you graph the YZ first. And the reason we're graphing the YZ first is because those are not the slanted ones. So the Y is 7, that means you go to the right 7. So 7's here, and I'm actually here at 7. I don't have to worry about being slanted. And then down 2.5. Okay, and I keep my trail going. And then -1. So -1 means on this x-axis here, I want to go back 1. Okay, so this is my center. Now, how are you going to draw yourself a sphere? Okay, so we said it's about 8. It's a little more than 8. So what we have to do is we have to go up 8, but that's hard to do. It's like hard to estimate where up 8 is. So draw a path, oops, to your C. Let me erase that. Okay, so draw an up radius and a down radius. And I want to go 8. Okay, so you're going to have to go a little more than 8. Okay, and then you're going to go to the side. So you're going to go the x-axis that way and the x-axis this way. And then for the y, you're going to go to the right and to the left. Am I making my squares too big? Let's see. 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's a little farther over. Now, what I like to do is out of 4 of them, I make a circle, and then the other one I make the ellipse. So here's my ellipse, and then the other ones I make a circle. And that's kind of looks like my sphere. You could also connect different ones. Like if you preferred, you could do this one as your loops, as your ellipse. I think that looks more normal. Doesn't that look better? Let's erase that one. My diagonal one looks funny. There you go. So there's your sphere. It doesn't have to be perfect. Try to leave breadcrumbs so you could see where everything is. You are estimating. Okay, and you're going out and left, right, up, down, and forward, backwards. So that's different than usual. Anyway, that's it. This is, I'm not sure which assignment this is for. This is for the homework assignment on 11.1.